All right, here's an example that I want to show you that involves a couple different things that we have been talking about that make it a little bit more tricky. Okay, so we want to verify that this identity is true. Okay, now remember that because it's an identity, or that we're trying to verify, we don't know that this is equal yet. We're trying to prove it's equal, so we cannot move from one side, we cannot move terms from one side of the equation to the other. We technically don't even know it's an equation yet. That's what we're trying to show. Okay, so nothing can go from one side to the other. It's very tempting sometimes, but you can't. All right, so let's take a look at our rules that we have real quick, right? We want to look for identities that we can substitute. Now, one of the things that jumps out right away that we've always kind of said is, look at you've got a bunch of squared terms in here, and there's some addition and subtraction. So maybe there's a Pythagorean identity that we could use. Okay, but not yet. Okay, there's a little too much going on in this term to be able to use it. Okay, so let's look for terms that can cancel out. Well, the only thing being multiplied together is this, but cosine and cosecant are not reciprocal, so they can't cancel out. All right, use your algebra. See if something can be factored out. Okay, now look at this. You've got two terms. They both have a cosecant squared. Okay, so that can be factored out. And remember, when you're factoring, you're dividing it out. So we're going to divide both terms by cosecant theta because that is the GCF. Okay, it's just like when you were factoring normally, you always look for a GCF first, right? So we're kind of looking for that. Okay, it's the same thing, it's just not an X or a Y, it's this thing. Okay, so the cosecant squared was the GCF, so that's coming outside. Cosecant divided by cosecant squared, cosecant squared theta divided by cosecant squared theta is 1. Okay, these are going to cancel out and leave us with just cosine squared. Okay. Now, again, as soon as you do a step, go back and let's take a look at our steps again. Let's come back to our rules. Okay. Look for identities to substitute. Okay. What do you notice? Now that we've kind of taken something out, is a little bit more obvious that we can use a Pythagorean identity somewhere. Well, yeah, look at this. We've got 1 minus cosine squared theta. Now, if you look at your Pythagorean identities, it doesn't look exactly like any of them, but it's really pretty close. It's got a couple terms that have the same thing, or that are involved, all right? And now because this is a 1 and that's just a cosine and we don't have this complicated thing anymore, we can probably do it, all right? So look for the Pythagorean identity that has the terms that we have here. We have a 1 and we have a cosine squared. Well, sine squared plus cosine squared has both of those. Okay, and if you watch the video, and again, you're gonna try and I made a whole video on just how this works and how you can rearrange them. Okay, I'm gonna show you a little bit here, but if you're confused about it, you can always watch it more there. Remember, we want it to be 1 minus cosine squared. So we want one side of our identity to be 1 minus cosine squared so we can replace. To do that, we're just going to subtract to the other side. Now, I can do that in this case because it is an identity. I know it's true, so I can move things from one side to the other. Okay, so now that I have that, it shows me that 1 minus cosine squared theta is sine squared. So I can replace all of this 1 minus cosine squared with sine squared. Okay. Now, next step. Identities. We don't really have any because we don't really have any Pythagorean identities because there's no addition or subtraction. Okay. Look for things that can cancel out. Right. Get comfortable with what the reciprocals are. right? Cosecant and sine are reciprocals, so they cancel each other out. And even though they're squares, it's still the same thing. Just make sure that they're both squares or they're both single terms, okay, so that everything can cancel out. And that would just give you 1. Now, if you don't recognize that or see that, you can always take this and make it that, if that makes it easier for you. And now you see that it's just that. Okay, and don't forget, when you're verifying, you need to have both sides of the equation to be exactly the same thing. Otherwise, you haven't technically proven anything yet. All right, but we did there.